Hi, in this video, we're going to talk about VLAN Trunks. Okay, so VLAN Trunks is a VLAN trunk is a point-to-point link that carries more than one VLAN. So it's a way to extend VLANs between two switches. Okay. Cisco supports the IEEE standard 802.1q. However, you might see on some older Cisco switches that it supports the Cisco ISL, inner switch link. All right. So how do the switches do this? Okay, so what the switch does is when it needs to send an Ethernet frame between two switches that is configured as a trunk link, it actually inserts a tag known as the VLAN tag, the 802.1q tag. And there's several fields that are in that tag. So let's take a look at what those are. But first of all, let me mention that the tag is created, this tag is created when, by this, let's say a Ethernet frame is being sent from A to B, but any frames, as they exit out of this switch, the tag is put on here, and the tag is removed here. Okay, so it's added here, and removed, I'll use an R here, and removed there. Okay. All right. So let's take a look at what are these fields in this tag. Okay, the type field. This just says that this tag is being carried, is encapsulated within a 802, an Ethernet frame, 802.3 frame. Priority. This is used by quality of service to give priority of some frames over others. Talk about this more when we talk about QoS issues in other videos. Canonical Format Identifier, CFI. This just happens, the only time this is used is with legacy token rings, so I won't even go into that. But here's the field that we really want to talk about, the VLAN ID. So this is what identifies what VLAN it came in on. And so let me actually go back and talk about it right here. So what happens is, let's say that an Ethernet frame is being sent from a device on VLAN 10 port. So this port here belongs to VLAN 10. And is, let's just say it's a broadcast, okay? So we have these other ports, all three of these ports here belong to VLAN 10. So I'll put a 10 there, a 10 there, a 10 there. And actually I'm gonna put a couple of ports here, and these will be on VLAN 20, okay? And just so to make this seem a little, there we go. We have another port here. Let's make this VLAN 20, this port here. Okay, but let's say A is doing an ARP request for Z. They're on the same VLAN ports because they belong to the same IPv4 subnet. So a broadcast sent into this port is going to be sent out all other ports belonging to VLAN 10. And I'm going to put another port here, make it VLAN 10 here as well. So it will be sent out this port. It'll also be sent out this trunk link, because this trunk link belongs to, in this case, all VLANs. And it's going to get the VLAN identifier, VLAN 10. Okay, so when it reaches this other switch here, the other end of the trunk link, this switch is actually going to remove the tag. But it knows that this Ethernet frame was associated with VLAN 10. So it's only going to send this broadcast out any ports belonging to VLAN 10. It will not send it out these ports here belonging to VLAN 20. Okay. All right. So that's how the tag works. Quite simple. Again, it's added by the sending switch and removed by the receiving switch. All right. All right, so what's the native VLAN? We had talked about that previously. Well, this is for any devices that do not support tagging. It's something that we really don't need to deal with anymore, but we still need to make sure that that we accommodate for it, because Cisco switches still look for at least one of our VLANs being the native VLAN. Okay, so all trunk links must have a native VLAN. It's part of the 802.1q spec. So even though we don't really deal with the native VLAN anymore, we don't have to worry about it anymore, 802.1q says all trunks must have a native VLAN. Okay? And it must be the same on both ends. So that's the one thing you need to be careful of. You need, when configuring the native VLAN, if you make it a VLAN other than VLAN 1, which it is by default, then you need to make sure that both ends of the trunk, both switches, are configured for the proper VLAN. We'll do that in a moment, or the proper native VLAN. Okay, so we can modify it. So as you see here, I created a VLAN 200, which is our native VLAN. Really, you can, if you don't, by default, the native VLAN is VLAN 1, and you can leave it as that. So let me just kind of go through these next couple of bullet points here. Okay, the native VLAN should not be used for any user VLANs, 10, 20 user VLANs, not the voice VLAN, not the management VLAN. Okay, VLAN 1 is for our control traffic. So our control traffic is all of this stuff here, right? STP, DTP, VTP, and all that kind of stuff. Okay, and that's control traffic is always going to be sent over VLAN 1. If VLAN 1 is untagged, which it is by default, that's our native VLAN by default, is the native VLAN, that's fine. It just means the control traffic goes across this trunk link untagged. If you change the native VLAN to be another VLAN, like VLAN 200, that's fine. Our VLAN 1 control traffic going across VLAN 1 will now be tagged. It doesn't matter to the control traffic, okay? And it just means that VLAN 200 is for any of our untagged traffic. For all those devices, we don't care about it anymore. All right, but the most important thing is that both ends of the trunk link, both switches, know what is the native VLAN. They both agree to what it is. Okay, so it's fine to leave VLAN 1 as the native VLAN. All right, so trunking, we have, you know, this is by default, everything was on VLAN 1, right, before we created VLANs. If I was going to create a couple more VLANs on these two switches, VLANs 10 and 20, I mean, one way I could do it is have a link between every two switches, between the two switches for every VLAN. So this one here would be VLAN 1, this would be VLAN 10, this would be VLAN 20, and the corresponding link on the other side, VLAN 1, VLAN 10, VLAN 20. And if I added another VLAN, VLAN 30, I needed to pass that traffic between the two switches, I'd have to utilize yet another link and associate those ports to VLAN 30. Oh, what a pain, huh? Okay, you can see that that's not the best way to utilize our switch ports. Much better way is to use a trunk link, a single link that will carry all VLANs. You need to be careful that a lot of times we use this between switches going upstream. And this is typically going to be our higher bandwidth links. So our user bandwidth links might be the fast Ethernet ports, and our upstream links, our uplinks might be the gigabit ports. Okay. All right. So show VLAN brief command on VLAN on S1 and S2. Okay. We can see that right now we have all of our ports in one of the three VLANs, 1, 10, or 20, but including fast Ethernet 0, 1 on both ends. Okay, but we want to make this a trunk link to carry all the VLANs between these two switches. Right now, the only VLANs that can communicate between S1 and S2 are actually VLAN 1 traffic. Okay. This right now, we've associated both of these ports to VLAN 10. So let's change that, right? Okay, so I'm going to go on switch 1, interface fast Ethernet 0, 1. No, first of all, I'm going to say no switch port access VLAN 10. I'm going to say switch port encapsulation .1Q. This command here is only needed on those old Cisco switches or any Cisco switches that support the legacy ISL. By default, the VLAN trunking will use .1Q. Well, not by default. If it doesn't support ISL, then it will only support .1Q, 802.1Q trunking. Okay, then I just say switch port mode trunk. And that's all there is to it. Let's go over to switch S2, interface FA01, no switch port access VLAN 10. That's what we had it on. I'm going to say switch port mode trunk. Okay. Now let's take a look. I do show VLAN and notice that FA01 on, I'll do it over here on S1 since that's what we're looking at, is not in here. It's not, isn't listed anywhere here. Okay. Because it's not a member of 1, it's not a member of 10 or 20, any of those 3 VLANs. Okay, so this command here only shows you those ports associated with specific VLANs. It does not show trunking information. For that, we need show interface trunk command. Let's take a look here. Okay, so if I do show interface trunk, I can see, oh, okay, on S1, there it is, FA01. It is a trunk, it is trunking, it is on, so the status is on. The encapsulation is 802.1Q. And there's that native VLAN, okay, because we haven't changed anything. The native VLAN is 1. Now, where that is important is when we look at S2. Okay, by the way, it's by default, all VLANs are allowed on the trunk. And we'll see later how we can restrict that if we want to. Okay, look at S2. So now I'm on S2 here. Okay, notice same native VLAN. That's what's very important. Of course, the encapsulation is also very important. Okay, but now we only use 802.1Q. But this, okay, needs to be the same on both ends. Okay, all right. So just a little bit about creating VLANs. Just a little bit on the best practice and that sort of thing. So as you can see, we have VLANs 1, 2, 3 here, 11, 12, 13, 21, 22, 23. What you don't see here is we have a building here, and it has, let's say, VLAN 3. We really shouldn't use a VLAN 1, right? For a user VLAN. We have VLAN 3 here. Notice that it's not on any in any of the other buildings. There's some best practices associated with VLANs. One of the best practices, and this goes beyond what we really need to worry about right now, but let me just kind of mention it. The best practice is not to span VLANs across multiple access switches. So if you have VLAN 3 on this access switch, even if you're in the same building, don't have it span across other switches. If you need more ports for VLAN 3, there's a way you can do it with connecting multiple switches and called stack switches and make them look like a single physical switch. But the reason for this, and this gets way beyond where we're at, but I just want to keep this in the back of your mind for right now, is the reason why we don't want to span VLANs across multiple access switches is in larger environments. In small environments, it doesn't matter, but in larger environments, it can create a problem with something called asymmetric routing. And I won't go into that here, but this has to do when the upstream multi-layer switch never learns about device, where that device is on that access layer switch, and it constantly is flooding frames out all ports for a specific VLAN. Again, more than we needed to know, right? so don't worry about it. An access switch, however, can have multiple VLANs associated with it. All right, we'll keep it simple for now. All right, so that's it for VLAN Trunks. More on routing VLANs and other things like that coming up on other videos. I also have videos on VLAN trunking protocol, a dynamic trunking protocol, and all kinds of cool things associated with VLANs.